Good afternoon. It's going to take a few minutes for all the attendees to come in when I first open up the webinar. So we're going to give people a minute or two to find their way in. Oh no, that's not what I want at all. All right, so it looks like people are finding the chat already, which is great. The way we run these webinars is that, we've got over 100 people registered. I don't know how many people will actually be here live, but because we want to open it up to as many people as possible, we don't run these like a regular class. In a regular class, we maybe have a dozen people. We encourage everybody to turn on their cameras and their microphones. In these larger events, you really just have the chat. And so, let me just put in hello from New York City. That's where I'm coming from. If you want to throw in where you're coming from, that could help people see where you're. And in the chat, you can chat to everyone so everybody can see it. There's also a way to add a question just to the panelists, which is really me. But this is an AWS Discovery Day. AWS has built these series of webinars that authorized training partners like ExitCertified are allowed to deliver. And there's a series of them. There's one just sort of intro to cloud. There's one on migration. There's one coming up next week on machine learning. The ones that we've already done, there's one on security. Those are up on our website, so you can go and find those. I'll show you how to get to those a little later. This Discovery Day will eventually be recorded. You'll get an email with the link to it. So you can watch it again after. I'm not allowed to share the slides. AWS says, no, you can't share the slides, but you are allowed to record it. So there'll be a recording there. And my name is Miles. I work for a company called ExitCertified. We've been an authorized training partner of AWS for a long time. I think 2014 is when we first started teaching classes, when I first started teaching AWS classes. But we do a lot more than just AWS. We're partnered with all the major cloud vendors, so Microsoft, Google, Oracle, and a lot of other vendors like IBM and VMware. And so where there's a vendor of record, we partner with them and we deliver their authorized training that they've created. We also do other, sort of training on open source stuff as well. So I'll maybe talk a little bit more about what ExitCertified does near the end of the session. I'll also talk a little bit about a promo code. We have a summer promotion going on where you can get up to $100 per day off of a technical training class. So we'll come back and talk about that, but that's the company that I work for, and you'll see that logo down in the bottom right of all these slides. And so I think the number of attendees is leveling out a little bit. It's a little lower than, a lot of people sign up for these seminars and then they don't, they just wait and watch the recording, I guess. But you get the option of asking questions in the chat live. So please feel free to do that whenever you want. I've got one eye on the chat. I may not see it right away, but I'll get there eventually. So this session is all about data and what data means within an organization, and really the idea of a modern data strategy, which is often driven by the cloud. Okay? And so AWS has got a couple slides up here up front just talking about some stats that they've gotten from a Forbes article and a few other places. But this idea that the next wave of reinvention will be driven by data, I think is a sentiment that a lot of people understand. And so there was a nice article in Forbes where they talk, and they've quoted a couple things here where a typical Fortune 1000 company, if they make even 10% more of their data accessible to decision makers, they figure that there can be quite an increase in their income. And so, those numbers, they've got some things to back it up. But that idea is that there's sort of kind of three main things that the business gets out of increasing the amount of data that we give to individual practitioners within our company. One is that operationally, looking at how, there's a lot of data that you collect about your organization and how it works. By sharing that data around, we can certainly run our business more efficiently, looking for, how best to do things. But probably the biggest one is this: making more informed decisions. Every decision maker I know these days wants to be seen as making data-driven decisions. Because if you're not making a decision based on data, what is it, gut instinct? Like it's hard to justify your decisions if you can't point to some data. And so getting all the data you need to be able to make those decisions is important. And then once we've collected a lot of data, now we're seeing that making decisions going forward, we've got machine learning and AI to really help with that. So we can unlock some opportunities that used to be too difficult or even impossible by automating these things with AI and ML. Now, to be a data-driven decision, data has to be an organizational asset. It can't be just, this area of the company owns its own data and nobody else gets to see it. The data has to be accessible by anybody who's allowed to look at it. And we need to put it to work, right? Which really means, doing some engineering with that data and maybe doing machine learning. There's a lot of challenges that go into it because, first off, we have more data than ever before. I think about my first job out of college in the mid-90s. I worked as a database developer, and every piece of information in our database was typed by a human at some point. And that's the way it used to be. Now there's so much machine-generated code that it's just the explosion of data. And so, we've got all kinds of data. It might be right now stored in different silos, so that can be a problem. We want to adapt concepts adopt ideas of machine learning, but that is kind of a skill that, eludes a lot of individual developers. But also, increasingly, this data that we have is being governed by all kinds of, maybe compliance organizations, maybe the government themselves have rules on what you can and can't do with it. And so just holding that data becomes something that you have to really, manage and govern. There's also things we learned even from the pandemic over the last few years. To survive, we have to make better and faster decisions. Data is critical to that. To thrive, we want to be able to put our data to work, figure out new customer experiences. So some of the use cases that we use this data for, I mentioned one of them is just operationally within my company, right? Trying to automate processes and optimize those. A lot of times you have to gather a lot of metrics to see, where are the bottlenecks in this process so that we can figure out how to get around them. Things like supply chain optimization, detecting fraud, right? There's a lot of that sort of operational stuff that we can do. Then there's more on the marketing side. A lot of times you hear about improved targeting to, ads to the right people, churn analysis, getting a 360-degree view of your customer, right? Figuring out, well, not just what have they bought from us, but what have they said in chats to our customer service representatives? What have they tweeted about us? Get all that information about that customer so that we can, really understand them better. And then maybe, when they go to use our website, let's try and improve that customer experience. So personalize it. Maybe if they do contact somebody in our contact center, that customer service rep has the history of everything they've told us right there at their fingertips, right? So there's a lot of things we can do on that customer experience side. And then finally, if you're a company that develops software, let's build some that incorporates all this data and analysis of that data. Now, one of the big problems we have is that some of our traditional approaches to data warehousing, if I think back to my first job back in the 90s, my company was at a crossroads. They were moving from a mainframe to more client server, and we brought in Oracle databases, but that was mostly for the transactional thing. And then we decided, let's go make a data warehouse, right? So we had all these different transactional databases, and we were grabbing data from those, bringing them into a central data warehouse, and then we would attach business intelligence tools to, go and make nice dashboards and reports and things. Well, the problem is, if you get a large enough organization, you're not going to have just one data warehouse. You're going to have a few. Each group has their own data, so we end up with those silos. And so the big thing, probably about 10 years ago, that we started to see was the concept of data lakes, right? Where we have, a central place where we can drop all of our data in its natural format, right? So if you've not seen this term before, I imagine most people have heard of it. That analogy is, a data lake holds all the data in its natural state. It might be a little dirty, right? Versus a data warehouse, which is more like kind of like bottled water, where you take some water, you clean it up, you package it up for a particular kind of use, right? But it doesn't mean that the lake isn't still very valuable, right? By not processing it, I have that data in its natural state. I haven't lost any context yet. So there's, different versions of where data can live to give us different options. And there's not just those. If you look at any kind of modern cloud-based application, you've not just got, relational databases, right? You've got all kinds of NoSQL databases. And so here's a typical kind of web page where, we might have the basic, shopping cart or whatever. That might be a relational database. But then we've got like just a list of all our products, and there's not a lot of movement in that. You add new products once in a while. You might change the price of a product or whatever. So you might use something like a key value store for that. When it comes to the customer reviews, you might put those in some sort of oh no, this one's the frequent accessories your friends bought together. That might be something you put in a graph database, right? And then up top here, you've got some sort of data in a nice format for search, right? So we have all kinds of, in AWS, what we call purpose-built databases, which are nice managed options for doing things like graph databases, key value databases, search data. And so, AWS has kind of put forward this idea that a modern data strategy doesn't ignore any of these things. Yes, you've got a data lake maybe at the heart of it, but you've also got your data warehouse. You've got all kinds of relational databases. You have non-relational databases. You have, log analytics stuff. You got big data processing. You got machine learning. All of these things are part of your modern data strategy. And so we want to be able to hold data at any scale. We want to pick the options that are going to give us the best price to performance ratio, right, depending on what we're doing. And ideally, no matter where this data lives, we should be able to get seamless data access to it. And, through this idea of the data catalog and governance around this data, we would like a unified governance where we say something like, okay, any kind of personally identifiable information, maybe you've got social security numbers, those need to be obfuscated wherever we store them, right? And so we need that across the board, no matter what kind of data store this data lives in. And then we also want to add in AI and ML, to solve those business challenges going forward. So this diagram is just sort of, descriptive relational databases, non-relational databases. If we go in and add some names to it, if you're just looking for a relational database, a lot of times these days we're talking about Amazon Aurora. One of the most popular, NoSQL databases in the AWS world is DynamoDB. When it comes to machine learning, we've got SageMaker. Redshift is our data warehouse. When it comes to search data, we've got Open Search Service, which you've probably heard of Elasticsearch. That's what that is built on. There was a bit of a fight between the open source, kind of group that was doing Elasticsearch and the company Elastic. They were trying to really clamp on too much and hold too much about that open source. So AWS spearheaded this idea to split off OpenSearch from Elastic. And then EMR, that is our Hadoop and Spark kind of environment. So, what we're really looking for in a modern data strategy is, kind of threefold. So we want to modernize our existing data infrastructure. So if you've got, a bunch of Oracle databases running on EC2 instances, we can get a lot of nice things out of modernizing that and saying, let's take some of the basic DBA duties off of our shoulders and let Amazon do it, right? So modernize, moving to more scalable, trusted, secure cloud provider options. Innovate, which is where we build new experiences and reimagine old processes using AI and ML. And then this idea of unifying, let's look at the best of both data lakes and those purpose-built data stores like our data warehouse. And let's put those all together. So let's start with the modernize part. There's a few things that customers are trying to do, and they've been doing this for probably about 6 or 7 years in AWS. This has been a big trend that I see. I see a lot of students over the years and talk to a lot of companies that are making a cloud transition. And a lot of them are trying to break free from legacy databases. And a lot of this was sort of spearheaded by Amazon themselves, right? They a long time ago came out with the relational database service, or Amazon RDS. And the idea was you're already letting your cloud vendor take care of the physical data warehouse, the sort of data center, right? So, power and HVAC and racks and servers and physical maintenance of them. Why don't we just let the cloud vendor do a little bit more? They can not only install the operating system, but patch it over time. They can install my Oracle database and patch it over time. I can set it up to take nightly backups for me. I can set it up so that one Oracle database isn't a single point of failure by launching a second one and setting up synchronous replication between it, right? So that idea of helping manage the database, moving to fully managed databases, has been an interesting one for a while. Then Amazon looked and said, well, they picked the two most popular commercial databases. So that's Oracle and Microsoft SQL Server. And then they did the same for the two most popular open source databases, MySQL and Postgres. And once they started looking at it, they said, with something like Oracle, you could either bring your own license if you already had an Oracle database license, or you could buy one, so that you just pay your monthly bill to Amazon and then they turn around and pay Oracle. So they really started to get an insight into what people are paying for Oracle and SQL Server, and it's a lot. And so what Amazon said was, maybe we can build a cloud-powered database that is maybe a tenth the cost of those, but still gives you the same sort of throughput and scale, right? And so that's where Aurora came in, right? And so that's sort of the idea. We want to break free from these legacy database providers, and we might get some nice benefits out of it. We're going to go to fully managed database services. We're going to do the same thing for our data warehouse, and start building our applications with modern sort of purpose-built databases. So let's start with that first, the old guard databases. They're very expensive. They're very proprietary, right? You end up with vendor lock-in. Right? Oracle, for example, has really started some punitive licensing, where if you're going to run Oracle in the cloud, unless you're running it in Oracle's cloud, it's going to cost you quite a bit, right? And so this is sort of the idea, and you're still stuck with these database providers who say, okay, well, that version's no longer supported. You got to move to a new version and pay more, So we're seeing a lot of people move away from that and go to like open source databases. But the problem with the open source databases is it takes a bit of expertise to make them run, with the same scale and throughput as those commercial vendors. So what we want is, I want it to look and feel like one of these open source, but have that commercial grade performance. And that's exactly what Aurora does. Right? So when Amazon built Aurora, they decided, database administrators, they've seen this story before. Oh, there's a brand new database. Great. Well, now I'm just going to use that. I'm going to be beholden to Amazon instead of Oracle, and at their whim when they decide to change things and pay whatever price they want. And so when Amazon built Aurora, they said, we don't want you to force into vendor lock-in. So what we'll do is we'll make Aurora look like either MySQL or Postgres. What does it mean to look like one of those? It means that for all intents and purposes, the code that you write that talks to the database thinks it's talking to MySQL. So it's using the MySQL drivers, it's using the MySQL SQL dialect. So just because I'm running an Aurora, I get that scale and throughput and everything I like about it. But if I decided to move this app outside of Amazon to another cloud or even to my own private cloud or something, I could go and launch a bunch of MySQL databases and do the backend DBA work to make them scale the way I need to, right? And so that's sort of the big benefit of Aurora. I get the nice performance and scalability much faster than if I just use the open source options. I get the high availability and durability. It's very fault tolerant. If the database dies, there's a failover right away. It's highly secure. It's fully managed. I get all that, but I don't really get the vendor lock-in part. And so, as soon as Aurora came out, it became wildly popular, right? A lot of databases migrating to Aurora. And it's not just Aurora. If you look, it's not just relational databases. If I'm using, I don't know, MongoDB or Cassandra or some sort of NoSQL database that I have to manage myself and deal with, maybe licensing, a lot of them are open source. It turns out across the stack, if it comes to databases like Oracle or Microsoft SQL Server or something, we'll go to Aurora or RDS maybe. When it comes to MongoDB and Cassandra and Redis and some of these different NoSQL databases, well, we've got DynamoDB, we've got Amazon Document DB, which has MongoDB compatibility. We've got Keyspaces, which looks like Cassandra. We got Elasticache, which is sort of an in-memory, looks like either Redis or Memcached. Redshift, in lieu of a traditional data warehouse appliance like Oracle's, well, it used to be called Exadata. I think it became called Data Warehouse. IBM Netezza, Greenplum, all those kind of database vendors. When it comes to Hadoop, we've got EMR. When it comes to Elasticsearch and things like that, the ELK stack you sometimes hear called Elasticsearch, Logstash, and Kibana. We got OpenSearch. MSK is managed streams for Kafka. And then SageMaker lets us use, a whole bunch of different machine learning frameworks like PyTorch or MXNet. TensorFlow is a big one. And so that's the big idea of, modernizing to these sort of managed services. When we talk about managed services, if I was to run, say, an Oracle database in my own data center on-prem, this is all the things I have to think about, right? You can imagine the low-level stuff, the hardware maintenance and some of that, just running on a virtual machine in the cloud. Amazon does some of that work. But if I move to a fully managed service, basically they do everything up to, maybe even providing some machine learning through SQL and APIs. Then I'm really just thinking about my data and, what's the structure. If I'm using a relational database, I think, what are my tables? What are the columns called? Where are the indexes? Where's the partitioning? And beyond that, I'm not the DBA. A brainless algorithm at Amazon is. So they're taking care of all the rest of that stack. Now, that might sound scary to some people. They said, well, what if I don't like the way that brainless algorithm does the administration? Well, you're not stuck using it. You can still use, what some people call infrastructure as a service versus platform as a service. That's the beauty of the cloud. There's a lot of options. So you can run things the way you want. But a lot of organizations these days are looking, going, hey, I never enjoyed paying, a bunch of Oracle DBAs just to keep an Oracle database running, which is the same work I have to do, your company has to do, every company has to do. At AWS, the chief technical officer, this guy named Werner Vogels, he coined this term. He called it undifferentiated heavy lifting. It's the same work I have to do, you have to do, just to keep this thing going. Let's get rid of that. I don't know how to stop that. Okay. Couple of things left here. AWS obviously is the focus of this. There's lots of cloud providers. They're all sort of getting close to the same set of services over the years. Somebody innovates, comes up with something new. A couple years later, all the other cloud vendors have it. But what we find is that AWS is definitely the most comprehensive and broadly adopted cloud platform. And largest customer base, probably the easiest to get somebody who has experience on it. But the big thing to understand about building your data stack is that it's not one size fits all. We don't just use a relational database for everything anymore, right? Modern applications require more performance, scale, availability. And so, where you used to maybe only have, the customers inside your company, now you could have millions of users for apps. And your data volume might be in the petabytes, even exabytes over time. And, more and more often, a lot of these apps require, microsecond latency, forget millisecond, So what we sometimes call web scale applications. Right? And so for that reason, we have a lot of different purpose-built data services. Right? At some very low level, you've got the idea of a data lake. Mostly just uses our object storage, S3, right? And then we've got a service on top of that called Lake Formation that helps us actually set up the data lake, in minutes or in hours rather than weeks, And then we've got Glue, which helps us with ETL and building a data catalog, things like that. Then we've got all those databases we just mentioned. Then we've got the analytics side, right? So if you want to do Hadoop or search stuff or messaging, we've got a bunch of specific services for that. Then on top of that, we've got all these business intelligence like QuickSight, that's just the AWS services. Then there's many third-party companies doing the same thing. So if you like Tableau, you can use Tableau. If you want more of a managed service, you could go to AWS and use QuickSight. It looks at some level a lot like Tableau. Maybe it doesn't have all the bells and whistles, but it might have what you need, right? And so, we've got a lot of stuff. When we talk about machine learning, here they mentioned there's some really high level machine learning stuff. Things like, that's a good example, transcribe, comprehend, translate. There's a lot of these machine learning services that were just something that Amazon, had built and trained some models internally and been using for years. And then they turn around and said, oh, I bet our customers would like this, right? So all the components that make up the Alexa, where you say, hey, Alexa, do something, it's got to figure out, speech to text, and then do some sort of, understanding natural language processing on that text, figure out what they're looking for, and then figure out a response, and then turn that back into text, into speech, right? So all those elements are individual services that we can use. And we can use them without really knowing much about machine learning at all, right? I could just have an S3 bucket, load thousands of images into it, and then say, I'm going to use Amazon recognition to go and index all those images, and then come back and say, show me all the images that are of a woman wearing sunglasses, right? And I want you to be 95% sure, right? And it says, okay, here's the ones I think are a woman wearing sunglasses. I don't need to know machine learning to do that, right? But if I am a machine learning practitioner and I have very specific things I want to build using maybe TensorFlow or something like that, well, then I've got SageMaker to help me with that. So we're going to come back to that innovation side of the machine learning, but let's talk a little bit about the unify part. We want to put our data to work, right? So we need secure and well-governed access to our data using both data lakes and those purpose-built data stores. So let's come back to that concept of a data lake. We said it's a place where you just store all your data, right, in its natural format. So what do I need? I need some sort of storage that can hold any kind of file, and ideally not lose it, right? And be a cheap place to store things. And so, in the AWS world, the most obvious candidate for where to store a data lake is Amazon S3. right? Because it's cheap storage that's very durable, and it can hold any kind of data. Now, if you think you're just going to make one S3 bucket and say, there we go, I've got my data lake, just start dropping files in, you can get in trouble in a hurry because, sometimes we call that a data swamp, right? You just have unregulated data. Anybody can drop data in there. You don't know where it came from. You don't know who's allowed to look at it. There's no way to search it, right? So a lot of times, to be really a data lake, you need not just storage, but you need some sort of a data catalog to keep track of that data, where it came from, who's allowed to access it, things like that. But S3 is the ideal place for storage because it's very highly durable, right? We like to say 11 nines of durability. What that means is if I upload a file to S3 today, the chances of Amazon losing it in the next year are 0.00000000001%. Right? Now, how do they come up with those numbers? It's hard to say, but the idea is when you upload a file to S3, it's going to copy it to 3 different physical locations that are geographically separated, right, across multiple AZs, or availability zones. Each availability zone is a cluster of data centers. So when AWS builds infrastructure, they build a cluster of data centers, and then miles away they build another cluster, right? And then miles away they build another cluster, and those 3 AZs together make up a region. Some of the regions have more, right, than 3, but that's the big idea. And so, they've built these AZs close enough together that they can, replicate that data pretty quickly between them, but far enough apart that if there's some local disaster that takes out this cluster of data centers, it shouldn't affect this one over here. So very good durability and availability, scalability. Well, when I create an S3 bucket, that's what the top level namespace is called. I don't tell it how big to make it. It can hold an unlimited amount of objects. Right? There's no size restriction. Now, there are some physical size restrictions, but individual companies really don't run into them, because Amazon is just growing all the time, right? They're always adding more capacity to existing data centers, adding more data centers, adding more availability zones. Everything's growing nonstop. There's something called intelligent tiering, because we actually have within S3 different tiering. If you say, well, this data, I might need access to it quickly. So I'm going to pay a little bit more than if I store it in more of an archival form, where I say, this data, I'm not going to access it very often. So save money on storage. I'll pay a little bit more every time you access it. So we have sort of infrequent access. We have the extreme of that is something called Glacier, which you can imagine the name indicates it's cold storage, very slow moving. But intelligent tiering says, well, if I don't know what the usage patterns are, I'll throw it in there. It'll start in standard, and if you don't use it, it'll go to infrequent access. And then if I do use it, it'll move it back for me. And with S3, because it's not regular block level storage attached to some virtual machine, it's just internet storage. That means the way I access it is through HTTP or HTTPS gets and puts, very simple API. Anybody with the right permissions can put data into S3 or get data out. And it doesn't matter what the nature of the data is. To me, it's just some sort of binary object. So that's some of the things that make it, and it's very cheap. It starts at about 2.3 cents per gig per month for standard storage, and then it goes down the more you store. There's some, tiered pricing. So a data lake is very often sort of the root of a modern application. And so some people will start like inside out. They'll start by just dropping all the data into a data lake and then pull it from there and pull a subset of that data, put it into our data warehouse, because I know that there's people with BI tools that are looking for a subset of that data to do really, really fast queries all the time. Right? The other option is, naturally your applications are generating data in different relational and non-relational databases, and I'm pulling that data from the outside into the data lake. And then there's sort of like around the perimeter where, the data can live anywhere, right? And so the terminology that you see used now, and some people will put it as one word, sometimes it's written as 2 words here, is this kind of concept of a lakehouse architecture, where we say, I don't really care whether my data lives in the data lake or in the data warehouse or even one of these other, purpose-built databases. I'm going to have the same unified data access and unified governance to that data no matter where it lives. And so as long as I have a way to query that data wherever it lives, so that might be through Amazon Athena. We're going to talk a little bit about that coming up. Then I'm not so worried about where the data lives. And where it lives depends on really that price to performance ratio. Now, we've sort of gone over the purpose-built data services, but we didn't talk too much about Athena or EMR. So it's probably worth talking about those now. So the big idea with Athena is just this way of querying data wherever it lives, whether it's well-structured files in S3, or if it's in a relational database or in a NoSQL database. I want to have this sort of SQL front end to get that data no matter where it lives. Now, it's a bit of a different trade-off. If it's just data sitting in S3, it's probably not going to query as fast as if it's in a well-structured relational database, especially in Redshift, where they've got all kinds of sort of acceleration for how we access the data. And with Athena, what you're doing is you're paying every time you run a query, you pay for how much data gets scanned. But you're not paying for anything when the data is just sitting there. You're paying for storage of the data, but you're not paying for a query engine when we're not using it. So it's really good for interactive type query. There's also something in Redshift, the data warehouse, which is a little bit like Athena running inside Redshift, called Redshift Spectrum, which says, hey, you can come in and use your regular Redshift querying to query tables in Redshift or external tables, maybe well-structured files in S3. And for those part of them, you're going to pay per query, per how many gigs get scanned or whatever. So it's a very similar to Athena. So that's the two ways that you see people do that unified access to that lakehouse architecture, is either using Athena, or if they're more Redshift centric, then everything goes through Redshift Spectrum to query whether the data is in Redshift or somewhere else. The other ones we mentioned, EMR. EMR originally stood for Elastic MapReduce. MapReduce was the original data processing framework inside Hadoop, but that's been supplanted by things like Spark and Flink and all kinds of stuff. But EMR just means, hey, I need a cluster of machines that are going to do some sort of Hadoop processing, no matter what framework we use on top of it. OpenSearch, we said, was for holding data in a way that it's optimized for search. So you can imagine when you go to Amazon.com and you say, hey, I want to find, golf clubs or something, down the side, you have that sort of faceted search where it says, oh, show me only things that have 2-star reviews, 3-star reviews, 4-star reviews. You also have different price between this price and that price, or between this price and that price. And when you click one of those, it quickly sifts through that list of thousands of results and whittles it down quickly. That's what we call faceted search. And if you search the data in the right format to begin with, it can make it very easy to then filter it by those different facets. That's the kind of thing that OpenSearch service really helps with. Kinesis and MSK are both ways of dealing with streaming data. So a lot of times when we talk about like a data warehouse, you say, well, how did the data get in there? It was either batch processed, where we had a bunch of log files sitting around, and then nightly we do some sort of big Hadoop job running Spark or something to grab all that data and massage it and put it into the Redshift database. Or if I've got maybe thousands of little sensors firing every 100 milliseconds, we have a steady stream of little bits of JSON coming in. I need to process that. That's stream processing. Well, there's a product out there called Apache Kafka, which is wildly popular for doing this. Amazon built their own service called Kinesis that also helps with that. And so now we have two different services depending, if you were kind of working before Kinesis or working outside of AWS and you're using Kafka, we've got MSK. If you're just going with Kinesis, well, then that makes it easier inside AWS. So we've got a few different services there. So these are some of our data services that aren't necessarily holding the data, although Redshift is definitely that. Redshift these days has about a 3-time better price performance ratio than other cloud data warehouses. You know, for a little while, I would say they were getting they were really getting beat badly by new vendors like Snowflake. Getting some weird sun coming in on me. Yeah, it looks really weird, doesn't it? But they've tweaked how they do things, and they've embraced some modern ways of doing things. So it's certainly gotten better. Sorry, I don't know how to fix this. There, just need a better angle. Okay. Yeah, so Redshift's come a long way, and it's certainly a lot cheaper than most of the other cloud data warehouses, and certainly a lot cheaper than the traditional, physical data warehouse appliances. Now, a little bit about that 3-time better price performance ratio. They've got some benchmarks that they've done. Problem with these benchmarks is, did they tune the other ones properly? I think what you can gain from a boast like this is that they made the changes so that they're not getting left behind by some of the newer vendors out there, right? And so you're getting at least as good performance as the other cloud data warehouses. But the big challenge with a data warehouse like Redshift is just getting the data in there, right? Where does the data come from? You got all kinds of data stores that you need to take that data, grab that data, massage the data, clean it up, and then load it into my data warehouse. So this is what we traditionally called ETL: extract, transform, and load. Right? The big challenges are, well, what if my source data is changing? What if my target data warehouse changes? Right? What if something's not available when I go to grab it? I need to have some sort of retry logic, right? And there might be some specialized ETL skills, right? If I'm trying to do this in parallel across a bunch of machines, I might have to learn Spark. Right? So there's a lot that goes into the ETL side. Right? And so if I want to break down these silos and get that data into one place, right, I need to do the ETL. I might want to make it easy for the simple stuff, like maybe do some sort of visual data preparation so that I'm not writing code to do very simple things, right? I'm going to have to replicate data between different places. I may have to move data to or from the data lake. And again, I want that federated query so that I can query the data, whether it's in the data lake or in the data warehouse. So when it comes to breaking down silos, using that S3 data lake and kind of thinking it as, well, we've got both places to store data. The data might be stored in both, or it might be in one or the other. I kind of want to treat it all the same. And so these days with Redshift, I can access the data that's in the managed storage. Of course, that's very easy. Or I can use Spectrum to go and query the well-structured data in S3. By well-structured, we mean, if we're going to want the same kind of data warehousing queries, we want it to be, compressed. We want it to be in a nice format that we can read quickly, maybe columnar storage, like something like Parquet format, right? And so Redshift is really good at doing this kind of thing. At some point, we're going to need maybe to standardize on some things. So that S3 data lake, it might be good if we can standardize on Parquet format so that it's, columnar storage. It's a nice open data format supported by, Hadoop and EMR, Athena, Redshift. I can export Parquet from Redshift into S3. I can use SQL with Redshift's unload command to export data in Parquet format. And the unloaded data is automatically registered in AWS Glue Data Catalog. That's the governance part. We need a central catalog where I say, here's a table. Is it a table in Redshift or is it a table in S3 in my data lake? Right? But keeping track of, okay, here's what the columns are called and their data types and everything, so that, no matter where I am, I can query that data wherever it lives. So that's where Redshift and Athena come in, using that catalog to grab the data wherever it lives. All right. Now, over time, Glue has become a few different things, right? At first, Glue had that data catalog, but it was more about building ETL jobs using Spark, but not having to go and manage the whole Hadoop cluster myself. It was more of a serverless kind of ETL. Over time, they've added more and more to Glue, and now they've got something called Glue Elastic Views. And what this is it's hopefully you've heard of this term, materialized views. In a relational database, if you think way back when you first learned about relational databases, you have tables and you have views. And a view is basically a select statement. It's like a window through which you look at the underlying data in the tables. The data lives in tables. A view just says, hey, I want you to grab these columns from this table and join them to these columns from this table. And now the view looks like a table. Like I can say, hey, describe it. I can select star from it. But the view itself doesn't generally hold data. It's just a way of simplifying my query so that it looks like I'm querying one table when actually the data is spread around different places. Well, the concept of a materialized view is where we actually run the query and grab the data and store it in this object. Well, those are possible to do all over the place. Well, Glue allows us to do that, so it can combine and replicate data from wherever to make these very simple tables to make my business intelligence tools or whatever that are querying the data much faster. And it's so it's continually monitoring the source database for changes and updating that materialized view. And it should do it all in a serverless way and handle the heavy lifting of copying and combining the data, where I don't have to do anything. And so, that Glue catalog and something called Lake Formation help with the unified governance around the whole thing. Lake Formation is really about setting up, creating a data lake. Like I said, it could be as simple as create an S3 bucket, say, there we go. But that's not great. I need to be able to keep track of who's got access to what. And then you've got problems of, like, if I make an Athena table on top of S3 data, you might have permissions on the table, but somebody might have also permissions to the underlying S3 bucket. So trying to set things up in a way where we have sort of a consistent security across all that data, that's where lake formation really comes in. So centrally defining security, governance, and auditing, consistently enforcing those policies no matter where the data lives, and integrating with the various services to make sure that happens. And we could do table level, database level, or even column level permissions. So this is what's really making data lakes wildly popular. Obviously, AWS, we've got a lot of data lakes in there. This is just a smattering of some of the kinds of companies that are doing data lakes. Not seeing a lot of questions in the chat. I don't know if I've not stopped long enough talking to see any, but I'm keeping an eye on there. I will break at the end. Maybe you're more comfortable at the end asking all the questions. So we'll see how we're doing then. Well, we're talking about this three-pronged. We talked about modernize, we talked about unify. The last piece is the innovate part, right? And this is where we're building new experiences using AI and ML. And this is a hot topic these days. I mentioned that AWS has sort of different levels of machine learning services. At the very bottom, they've got things like, I can launch an EC2 instance, a virtual machine that has chips that are really good for doing certain things versus other things. I could have graphical processing units. They have some that are better for doing inference, some that are doing better for training models, right? So at the physical level, they have, different chips and things like that. Then you've got the actual frameworks that are, not really built by Amazon, but things like TensorFlow and MXNet and PyTorch and all those. Well, SageMaker is the main tool that a real heavy-duty machine learning practitioner will use. Because when you look at all the steps in building a machine learning workload, it usually starts with, well, I've collected all kinds of data, right? Maybe the data is sitting there in my data lake, but I may have to label, right? There's certain machine learning algorithms that require the data to be sort of labeled in some way. So I might have to do that. Then I have to start collecting the data from different places, storing it, and then setting up what are the features on it. Then detecting bias and visualizing things maybe in notebooks, picking an algorithm from a very big list of algorithms, training the models with that, tuning those parameters, deploying it into production, managing that thing in production, right? So there's a lot to that. And SageMaker Studio is a nice integrated development environment that will help us do most of these things end to end, right? And allow us to productize. Like when I think about 10 years ago, when the term data scientist started to get thrown around a lot, and I worked in a place where we had a data scientist, and he was just this sort of cowboy working on his own, looking at data, doing experimental stuff. Well, nowadays, that job of the data scientist and the results that they produce is no longer just some little experimental thing on the side. For a lot of companies, that is mission critical. And so we have to productize this. It can't be just some little experiments we're running here and there. We have to build a repeatable kind of data engineering flow, right? And so SageMaker Studio can certainly help us with that. And then, the vast majority of developers are not machine learning experts, but we have all these top-level services. I mentioned Amazon Recognition with a K, not a C, make it easier, I guess, to Google or something. So we have all these different services where you can use them without really understanding the machine learning underneath, because they are things that Amazon themselves built and trained and used for a long time. So they've got some that do with speech and some that do with text. They even have some that are specific to certain industries. And so we might come back and talk about some of those. So if we look at what kinds of business problems we're using machine learning on, we mentioned at the top of the discussion that, enhancing your customer experience is a big part of it. Personalization, maybe contact lens, which is that, contact center, keeping track of everything. Optimizing the business. So gathering those business metrics, fraud detection, things like that. So here's a few of the services that have to do with that. Accelerating software development. Well, now we've got Code Guru, DevOps Guru, and probably the one that should be in the list, it's fairly new, is Amazon Code Whisperer. Right? They don't mention it in this presentation. They built this presentation last year, and so they're missing sort of that new thing. So maybe I'll just pop up so you can see what Amazon Code Whisperer is all about. Because that's sort of the newest thing. I'm gonna get this thing out of my way. Oh, it's really being a pain. Spell it right? Code Whisperer. Okay, here it is. Build applications faster and more securely with your AI coding companion. And so you may have heard of things like this. Everybody knows ChatGPT these days, right? You go, you sign up, you got to create an account. But I can go in and say, prompt ChatGPT and say, I want you to create a Python program that uploads a file called this into an S3 bucket called that. And you look at the code that it writes, and I look at that code and I say, oh, that's pretty good code. That's what I would have written, right? And so, a lot of people are worried, oh, AI is going to take our jobs. As a developer, it's just going to make my job a lot easier because I don't have to do a lot of that boilerplate kind of coding, the harness around the actual stuff that I want to do. In GitHub, they have something called Copilot. Again, that's using ChatGPT under the covers because Microsoft, Code Whisperer is what Amazon calls it. And they've now integrated it all over the place. So if you go to make a Lambda function, say I'm writing a Python Lambda function, I put like a little comment that says, I need a function that does X, Y, Z, and it'll suggest some code for me, right? So that's the big idea of Code Whisper. They've got plugins for all the major IDEs that you can imagine, like Eclipse and all the IntelliJ and all those ones, but also Cloud9, which is the main sort of cloud-based IDE that Amazon pushes. And so, so it's free for individual use, unlimited code suggestions. You can have it look at your code and do a security scan, and it'll look and say, it looks like you've hard-coded your AWS access key and secret key, that's a bad idea, and so there's, a few things that it's using AI to do inside there. And so that's kind of the newest thing I would say about the, the AI kind of companion on the application development side. And so, whether you use Code Whisperer or something else, that idea of, getting your code written quicker because you're letting the computer code it. There's a lot of these sort of low code / no code kind of initiatives, but Code Whisperer is the one Amazon has. I mentioned that there's a lot of these specific services that are really geared around a particular industry, right? And so here's some of those. Amazon Monitron, look out for equipment, look out for vision. So these, a lot of times in manufacturing, you might have all kinds of equipment. All this equipment these days is spitting out some sort of metrics, usually in the form of Internet of Things, right? So there's hundreds, thousands of sensors within your manufacturing plant that are just generating little bits of JSON saying, this is the ID of my sensor, here's my readings right now, right? And it's overwhelming, right? Like, what do you do with all that data? I can just throw it somewhere, but I want to proactively look at that and look for patterns that maybe the human eye can't see. I remember the first project I ever saw that was doing something like this. This was not even cloud. This was a long time ago. I did a lot of training with a company called Cloudera that was a big data company. And there was this electrical grid, quite a large company. And what they were doing was they had all these sensors on different transformers. And so what they were trying to do was figure out what are the, what's the scenario, can we figure out just before one of these transformer blows so that we can kind of reroute the power and avoid that thing happening? And it wasn't things that the human eye could find, right? And so they were just grabbing loads and loads of data and doing some analysis on it and building these machine learning models so that they could say, hey, we're seeing some conditions that we've seen in the past right before something blows. So let's, reroute some of the power to avoid that. And so it's the same sort of thing, but, building those things from scratch is a bit of a pain. So that's what some of these do. So look out for equipment will actually do some sort of, look for anomalies in those readings. Look out for vision says, let's product defects using computer vision. So you got cameras on the assembly line and it looks and it says, that looks different than the others. So let's flag it, So there's all sorts of things like that. Panoramas, computer vision, existing cameras. Yeah, there's all sorts of things in there. There's even a more specific kind of data lake for storing healthcare data. So store, transform, and analyze health and life sciences data in the cloud at petabyte scale. And so, what they're really doing is saying, hey, Amazon says creating a data lake could be as simple as just making an S3 bucket. That's usually not enough. You're gonna have to have a data catalog. But we know that in the healthcare industry, you've got certain types of data that you're going to see over and over again. So like whatever HL7 data, things like that. We've got certain compliance, like HIPAA compliance, that we know we're going to run into. So we know that there's some governance we need to do in a certain way. And so let's just make a very opinionated way of building a data lake, so that you don't have to, do everything from scratch, right? So that's the big idea of that one. And I think the thing that you should really get the sense of, going forward with machine learning is that development can be complex and expensive. The practitioners are famously hard to find because, colleges and universities weren't churning out data scientists as quickly as people needed them. And so what we're finding is that anything we can do, to make that machine learning more accessible. So if all these steps are required, maybe have SageMaker help us with all those things, right? Or alternatively, instead of having people dealing with the low-level machine learning, let's build the machine learning into some of our existing products. So whether we're storing data in databases and querying it there, or a data warehouse, or even using business intelligence tools, let's add some ML capabilities to those services directly. So in Amazon Aurora, we now have Aurora ML, just like Redshift ML, even Neptune for graph databases. And what this is doing is it's saying, hey, I've got some data. There's definitely some data points missing here. So if you want, I could build recommendations that would suggest what the missing data would be based on, patterns that we found. And so we can do that kind of thing. Even in QuickSight, that's the business intelligence tool that Amazon has that, looks a lot like Tableau. When you're building your dashboards, you can add some machine learning capabilities in there without knowing a lot about machine learning, for the most common type things that you would want to do. Even Athena has an ML piece to it, so that, in those queries, I can ask for more. So this is the big idea. This is the modern data strategy on AWS. So modernize, we talked about that being, move to these, managed databases, maybe go towards open source stuff as much as possible. Then the unify was really, let's use the best of both data warehouses and data lakes and make the data available wherever it lives. And then the innovate says, now that we've got a data lake with all this data or wherever it lives, let's add ML into the mix so that we can, make better decisions about the future. So that's the sort of three-tiered approach that AWS has to modern data strategy. Now, I think originally we thought this might be a 2-hour session. I think it's going to be more like an hour and a half, depending on how many questions you got. But let's talk a little bit about next steps. This is a short presentation. You're not going to walk out of here and be an expert in the AWS analytics stack, right? Unless you already were. So how can you learn about this? Well, one is to learn at your own pace, right? There's a lot of stuff out there. There is AWS has Skill Builder, which is sort of self-paced. If you want lab access, there's many videos that you can use just with the free version of Skill Builder. But if you want to do some self-paced labs, you can pay for a subscription. And they give you access to a bunch of labs that you can do. You don't use your own AWS account. They give you timed access to one. Then you've got, actual classes, instructor-led. That's where ExitCertified comes in, because that's where we excel. We have lots of good classes. I'm going to show you some of those classes coming up. There's some ramp-up guides. Eventually, there's some certifications. The one main certification in this area is called a specialty certification called AWS Certified Data Analytics. Now, the problem with those specialty certifications, they're very highly advanced. They expect you to know a lot about AWS in general, but you have to have a very good breadth of knowledge on all the AWS analytics stack. And there's a lot to that analytics stack. So just to show you a little bit of that, let me bring up my console here. So this is an AWS account I use just for demos in class. And so if I just go to the list of services, actually I'm going to go here to all services. There. I know it's really small to read, but I just want to give you a sense of this is how many services there are in AWS in the management console. There's a few more that aren't in the console. And so if you're new to AWS, this has got to be very daunting. Okay, I can only imagine. You're like, do I have to learn 200 plus services? No. No, well, not nobody, but I'm sure very few people know all of those services. If you're not doing quantum compute, you're never going to use Amazon Bracket. If you're not doing anything with satellites, you're never going to use Ground Station. But if you look at the analytics part, well, we've got a lot in there. So we mentioned most of these along the way. Some of them we didn't talk really about because they're a little older, like cloud search. You wouldn't use that because these days you'd use OpenSearch instead. It's really just around because it was there before, right? You might use MSK, you might use Kinesis. You probably don't use both, right? There's sort of some competing things. So that's some of the analytics stack. Then you've got all the machine learning services that we talked about, and then all those different database services. Where'd they go? Here they are. So that's a lot of services that make up the sort of data stack, right? And learning all of them is a real, challenge. And so one of the things I wanted to show, if I can get it up and running here, let me just get rid of that for a second. Let me show you our learning and certification path document. So this is a document we made just at ExitCertified to kind of hit home, what classes you should take depending on your roles. So most of the technical tracks start with the 1-day tech essentials, then go on to like a 3-day associate level class. But if you're interested in the data analytics side, here it is. Let me blow it up a bit. So again, you would start with the 1-day tech essentials, then do, well, it doesn't really matter whether you do architecting or sysops or even developing on AWS. One of those 3-day associate level classes will get you the basics of how AWS works. Then we have a 4-day class called Building Modern Data Analytics Solutions on AWS. And that really gets you ready for that specialty cert, right? So we would say you first have to know a bit about AWS. So take a 3-day class, then take this 4-day class. But if you look at this 4-day class, what it really is, it's 4 1-day classes, right? So it's a 4-day class, but, and we do run it as a 4-day class fairly often. So August 22nd, September 12th. So some of them are marked as guaranteed to run. That's that GTR. That means if you sign up for it, it's definitely running. But if I go back out a level, you're going to see the data analytics classes. There's really 4 1-day classes. So typically people start with the building data lakes on AWS. That teaches them, how do we use S3 to build a data lake, and then all about AWS Glue for the catalog and for ETL type purposes. Then there's a 1-day class on Redshift. Right? There's a 1-day class on, where is it? Batch solutions. So this is really about EMR and Spark to a certain degree. And streaming, which is it's about half and half. It's a little more than half on Kinesis, say 60% Kinesis, 40% MSK, so Kafka. And, so that's the idea. It's those 4 1-day classes. So we do offer them as 1-day classes. So if you just want the data lake and the Redshift, you can take those 2 days. It'll probably be the Monday and the Thursday, and then the 2 in between you would skip, right? Or you can do all 4. But if your goal is to get the certification, you better take all 4 because you're going to need that breadth of knowledge. Right? And so that's, that's what I wanted to say about the classes that we offer. Those classes are designed and developed by Amazon. They give you a lab environment for 3 months to do. Are there any free classes that include some free labs to play in? That's a good question, Edward. I would say that, we do these kind of hour and a half sessions. If you're looking for free labs, there's really not much out there. If you create your own AWS account, there is some stuff with the free tier, but as soon as you get into something like Redshift, forget the free tier. You're going to be spending up a lot of money. So you're better off to go and get the skill builder, pay for the $29 for a month, and then run through as many labs as you want. You could do a couple months, get through quite a bit. But that's the lowest cost to get official AWS labs. There's some third-party like gray market stuff as well, but you never know how current it is and things like that. Where can we get the PDF? Oh, you mean this PDF? Oh, yeah, I can drop that into the chat maybe. Let's see if that works. Depending how your chat works, this may or may not work. Let me drop that learning path document in there. Some of you may see that now in the chat and you can download it from there. Maybe not. So it depends how your company works with it. I'm going to drop another file in here as well, because I'm going to talk a little bit about what else ExitCertified does. So I mentioned at the top, we are primarily a cloud training company, although we do other things that are not necessarily cloud. The bulk of our business is based around, well, AWS is definitely our biggest product line, but the other, 3 kind of public cloud vendors, and then all the stuff that goes around it, right? So, containers and cloud native, so Docker, Kubernetes, all that kind of stuff. We do all that training. Here on the analytics stack, we're partnered with a bunch of other companies like Tableau and Databricks and Cloudera, so if you want to take some of those frameworks, we've got them. Some of our newest ones are Starburst, and NVIDIA has a lot of machine learning type stuff. We have a couple good classes on Snowflake now, but whatever it is, this is just indicative of what we've got. We've got machine learning classes. Every one of these cloud vendors has their own machine learning flavors, but we also have just some basic, hey, I need to learn Python, I need to learn the Python libraries for data science, and then I want to learn some basics of machine learning, agnostic from vendors and tools. We've got all that. And so that's, we call this our cloud centrics diagram. It sort of shows the suite of, what we do from a training perspective. So I just wanted to kind of hit that home, and these things, if you click on them, that takes you to a part of our website on analytics, and then, you can click on a particular vendor, say I click on AWS, it takes me straight to the data analytics courses. If I click on some of these like Databricks, it takes me to our Databricks training page, and so on. So that's the cloud centrics diagram. I think I threw that in there. I just got a couple slides left to go here. So we talked a little bit about the certification. We talked about cloud centrics. We have a promo right now. If you are thinking about taking a course, so exitcertified.com/upskill. Let me go there. And then I'll put that into the exitcertified.com. What was it? Upskill 500. I think that takes me there. Yeah, here it is. So I'll put this link into the chat as well. It looks like you have to register by August 31st. So that's the end of our summer program promo, but you don't have to take the course until, it has to be completed by November 30th. So this promo code, depending on the length of the class, most of our AWS classes are 3 days. Some of them are 4 days. You get basically $100 per day off. If you do private training, so our public classes are running fairly often. Like we have the largest guaranteed to run schedule in North America of all the authorized training partners. So if you have one or two people, great. You can go into a public course. Some of those analytics ones probably run at least once a month for sure. But something like a very basic architecting on AWS, we run that every week, guaranteed, right? So we have lots of public classes if you want. If you've got a group of people, well, then we can do private training just for you. Either on-site, we'll send an instructor to you if you want that. There's some of that happening now. We could do it at one of our training centers. That's a little less popular these days. People don't want to travel just for training. Most of the training is virtual. The nice thing about doing a private class is you can decide, normally it's 3 8-hour days. You could cut it up over, 5 half days or something like that. You decide the hours. And if you don't want all the content, you could say, well, this 3-day class, can we do it in 2 because we're not using these services? Great, no problem. So we can kind of tailor things. But obviously, if you're trying to get the certification, you better learn all the material. But that's a trade-off, yeah. So we do a lot of private training. I would say if you have like 5 people, maybe 6 people, then all of a sudden it becomes much more economical to do group training, because then you get a lot of economies of scale. The 10th, 11th person you put into the class, it's much, much cheaper. And so that's our main business. And so that's the summer promo. I guess the last thing I wanted to show was those webinars. I mentioned that this is the second last in this series of webinars. So I think if I go here, I can find resources, webinars. There we go. So these are our most recent webinars. So this is today's. So if you click on that, it'll still get you to sign up. Next week, we have one specifically on machine learning. Okay? So my colleague, Chris Littlefield, will be delivering that. I'm gonna probably introduce him and help him with the chat for that one, because we expect a lot of people. Last week, my colleague Pete did one called Securing Your AWS Cloud. And the week before that, my colleague Craig did one on performing large-scale migrations. So those are all there. Let me throw that in here. And so this is where today's video will be. But because you registered, you're going to get an email specifically with the link. So if you came in late, not a problem. You can watch the recording. If I talk too slow, you can speed it up, all that good stuff. But there's some other stuff we have in here. I did this early this year, a public cloud comparison, sort of talking about the 4 main clouds and what they each do well, things like that. My colleague, who does a lot more of our Azure stuff, he did this 2-hour webinar on helping get ready for the AZ 104 exam. That's the most popular Azure certification, is the Azure admin. I think we've done some in the past on passing the cloud practitioner and things like that. So if you just keep poking around in there, we've got some good free webinars in there. Like I said, the big idea of this is to get you an idea of what the AWS stack looks like, and their big ideas of how to build a modern strategy. I'm going to stick around for questions. What you'll realize is when you go to leave, it will pop up a little survey. It's only going to take you 2 minutes. It'll just ask you like, hey, what did you think of this? And what other topics are you interested in? So we're just trying to, put our finger on the pulse and figure out what kind of the free stuff should we be doing. So if you can answer any of those questions, that would be great. And like I said, you should get an email. I don't know if it's today or tomorrow, some point where you'll get the link to the recording. Probably be tomorrow or the next day, I would imagine. And like I said, I'm here for a while. If you want to throw questions in the chat, I'm here to answer questions as long as you want. I don't want you to leave with any questions about AWS specifically and that stack of analytics options we have. I think we've lost a couple people, but like I said, good luck. I should put my email address in here. Let me do that, miles.brown@exitcertified.com. If you have any questions after the course, that's a good place to send them. Again, I don't know, some companies, the way they lock down Zoom, you might not be able to copy and paste out of the chat. Most of them you can copy and paste. You may not be able to get the documents that I sent through, but those are all on our website if you poke around a little bit. All right, I'm not seeing any questions, so I'll wait another couple minutes and then I'll shut down the call.